today we're going to talk about inference for linear regression. So linear regression line is in a straight line form, which is the y hat equals a plus bx, which is for the sample data. And the y hat is the predicted response variable, the x is the explanatory variable, the a is the y-intercept, which is a constant, and the b is the slope of the sample regression line. And then this corresponds to the true or the population linear regression line, which is this formula. And the sample variables are predictors of the population or true variables. So there's 5 conditions to check for inference for linear regression, and you can remember the acronym LINER. So the L stands for linear, and that's that the data is linear, and you can check the residual plot that there is no pattern. And then the I is for independent, so that the individual outcomes are independent of each other, or if it's without replacement, we can check the 10% condition. And the N is for normal, which you can check a residual graph for approximate normality, like a stem plot or histogram. And then the E is for equal standard deviation, and you can look at the scatter plot of the residuals above and below the residual equals 0 line in the residual plot, and then check that the vertical spread of the residuals should be roughly the same from the smallest to the largest x value. And then the R is for random, so that's that the data was collected from a random sample or randomized experiment. There's 2 types of inference you can do for linear regression. The first one is confidence interval, and the second one is significance test, and they're both based on t-distribution. And for both of them, the degrees of freedom is n-2. And you can remember that because there's 2 variables, x and y. For confidence interval, we use the state, plan, do, conclude procedure. So for state, we state that we want to estimate a blank % confidence interval for, and then you add your context. And then for plan, we write that we're using a t-interval for slope, and we check these conditions. And then for do, we use this main formula to find the confidence interval with b from the linear regression line that we found before, t star from the chart that you relate the % confidence interval and the degrees of freedom of n-2, and the standard error from this equation. And then once you get that, you do the conclude part, and you say that we are blank % confident that the interval from whatever it is captures the true slope relating, and then you add the context. For significance test, you also use the state, plan, do, conclude procedure. So for state, the null hypothesis is that the true slope of the regression line is equal to 0, and the alternative is that it's not equal to 0, and then you use the significance level of either 0.05 or 0.10. And then for plan, you use the t-test for slope with these conditions met. And then for do, you have the equation to find the t-value, which you can also use the standard error of the slope over here, and then use a table to find the p-value by relating it to the degrees of freedom of n-2. And then for conclude, you either reject or fail to reject the null hypothesis by connecting it to the significance, by connecting the significance level to the p-value, and then you can add context. Instead of doing the manual do part for both procedures, you can use a computer output. Okay, so you always use this line of the computer output, which is the explanatory variable, and this is just an example. But you use these 2 values for the confidence interval, so this is the b, which is the slope, and this is the standard error. And then for the significance test, use these 2 values, so this is the t value, and this is the p-value. Sometimes the regression line doesn't fit into the linear model, so you might use a power model or exponential model. So these are the forms that they might fit into, the y hat equals x to the p, and the y hat equals ab to the x. And then you can transform them to make them look more linear and be able to do the inference. So for the power model, you take the natural log of the y and also the x, and for exponential, you take the natural log of just the y. Here are some tips for linear regression problems. So you can remember the degrees of freedom as n-2 because there are 2 variables, x and y. And then you can also remember the exponential model because x is in the exponent. And then for transformations, the problem will most likely tell you which transformation was used. So you just have to put the data into an appropriate equation for that transformation. And then there's some common mistakes. One is not showing work when you use a calculator. Another is writing an equation for the transformed data without transforming the equation. And then here's some AP practice problems you can do on linear regression. So there's from 2004 to 2016, both forms that you can do.